Welcome you all. Today we'll discuss about the properties of the estimators of multiple regression model. The first property is that in the case of three variable regression model, the regression line passes through the mean y bar, x2 bar and x3 bar. This means that the regression line passes through the average values of the y, x2 and x3. That is, the regression line of multiple regression model or the two variable regression line passes through the average or mean value of y, that is y bar, x2, x2 bar and x3, x3 bar. That is, it passes through the mean value of y, x2 and x3. Or simply, the three variable regression line passes through the mean value of y bar, x2 bar and x3 bar. This also we have seen in the case of two variable model. Same way, in the case of the multiple regression model, also the regression line passes through the average or the mean value of the variables. Then the second important property of the OLS estimator is that the mean value of the estimated yi, the estimated yi is denoted as yi cap, is equal to the mean value of actual yi, that is y bar, yi cap equal to y bar. The given this can be proved as follows. Given yi equal to beta 1 plus beta 2 x2i plus beta 3 x3i plus ui, and given this equation also we have seen from the first normal equation we derived this equation. First normal equation was the sigma y equal to n beta 1 cap plus beta 2 sigma x2i plus beta 3 sigma x3i. This was the first equation. Then we divided the whole equation by n. Then we go to the that normal equation as y bar equal to beta 1 cap plus beta 2 cap x2 bar plus beta 3 cap x3 bar. From this we derive the beta estimated value of beta 1 or beta 1 cap, that is y bar minus beta 2 cap x2 bar minus beta 3 cap x3 bar. This equation is used for deriving the proof of this function. That is, here y cap equal to beta 1 cap plus beta 2 cap x2i plus beta 3 cap. Given y equal to beta 1 plus beta 2 x2i plus beta 3 x3i, we can derive beta 1 cap equal to y bar minus, as we derived by beta 1 cap equal to y bar minus beta 2 cap x2 bar minus beta 3 cap x3 bar. Then here this can be written as y bar minus beta 2 cap x2 bar minus beta 3 cap x3 bar plus beta 2 x2i plus beta 3 x3i. Can be written as y bar minus beta 2 cap x2 bar minus beta 3 cap x3 bar plus beta 2 cap x2i plus beta 3 cap x3i. Then this can be rewritten as y bar equal to these two terms are similar. This can be beta 2 into x2i minus x2 bar beta 3 cap x3i minus x3. Then x2i minus x2 bar equal to 0. That is, x minus x bar equal to 0. We know like that x2i minus x bar equal to 0 and x3i minus x3 bar equal to 0. This x2i minus x2 bar can be written as small x2i. Then x3 minus x3i minus x3 bar can be written as small x3i. That is why we usually write x minus x bar equal to small xi. Like that, x2i minus x2 bar equal to small x2i, x3i minus x3 bar equal to small x3i. Then take the sum of the equation 1 on both sides and divide by n. That is, then take the summation of both sides. This will give sigma yi cap by n equal to y bar by n. This whole term will be equal to 0. Then the remaining portion is sigma y cap bar equal to the actual y bar, that is y. That is the mean value, average value of the estimated yi equal to the actual mean value of the actual y. The mean value of the estimated yi equal to the mean value of the actual y. This is the second important property. Third property is that sigma ui equal to sigma ui equal to u cap bar equal to the 0. And third one is the residuals of ui cap are uncorrelated with x2i, x3i, that is sigma ui cap x2i equal to sigma ui cap x3i equal to 0. Then fourth one is the residual ui cap uncorrelated with yi cap, that is sigma ui cap yi cap equal to 0. Then third property is that as the correlation coefficient between x2 and x3 increases towards 1, the variance of beta 2 cap and beta 3 cap increases for the given value of sigma square. That is, as the correlation coefficient is denoted as R23 between x2 and x3 increases towards 1, the variance of beta 2 cap and beta 3 cap increases. And next important one is, for a given value of R23 and sigma x2i square x3i square, the variance of OLS estimators are directly proportional to sigma square. That is, they increase as sigma square increases. The variance of OLS estimators are directly proportional to the sigma square. Similarly, for a given value of sigma square and R23, the variance of beta 2 cap is inversely proportional to x2i square. That is, the greater the variation in the sample value of x2i, the smaller the variance of beta 2. Therefore, beta 2 can be estimated more precisely. A similar statement can be similarly for a given values of sigma square and R23, the variance of beta 2 cap is inversely proportional to sigma x3i square in the case of beta 3. And the next important property is that the OLS estimators of the partial regression coefficient not only are linear and unbiased but also have minimum variance in the class of linear unbiased estimator. That is, the OLS estimators of the partial regression coefficients are also follows the blue or the Gauss-Markov theorem.